Anybody stayed up to speed with Livy and Baby Grump? Cool. Me neither. I don't even know who they are. But I do know that we're going to do this problem real quick. So welcome back if you're watching the video. We have Ganymede. Period of 32 days. That's how long it takes to circle the planet of Jupiter from which it orbits. Io is another of these moons that happens to orbit Jupiter, and it takes 1.8 days. Now, we are told that it's 4.2 Galilean units away. Galileo was pretty awesome. He was able to work out roughly the diameter of Jupiter, and then as he looked and saw moons, he could look and see, well, how many Jupiters is between Jupiter and the moon. And that's all he's looking at. Just like we're asking how many Earths are between the sun and any planet, same idea. We're just shifting our focus. So looking at this, I need help writing down what we know. And if we want to draw a picture, we certainly can. It's not going to be super awesome. But give me anything that I know, because we're trying to find the orbital radius. Delilah, can you tell me any of the known information? So Ganymede has a period of 32 days. Now, looking up at stuff, how did we talk, or which letter rather, did we use for the period? Capital T. Very specifically capital T. Now, we're looking for something else and we're given another period here, so I need to make sure it's really clear. If I'm talking about the period of Ganymede, I'm going to use a subscript to write this out and be really clear. What would you guys use as a subscript? G is fine with me, especially if we have this like completely locked in. I'm going to write it all. You do not have to. My only thought and why I would ever do this, and I would never do it on my page, is anything else that we've talked about ever that might be represented by a G, gravity. As long as you know the context of the problem, though, I don't think you need all this. Okay, the period of this is 32 days. Got it. Another piece of known information, Angel. Can you say that like 5 times louder? Okay, love it. You're highlighting this part. How would I represent that here? What do we use for orbital period? Which letter? T. And we're talking about which moon? That's the planet. Io. 1.8 days. Now, I don't think that this, and I guess it's kind of listed here, but if you didn't catch it when you read it, I'm just going to scroll down here real quick. Which of these moons is closer? Has to be. Look at how much faster it is, right? Cool. Anything else, Riley, that I might know about this? What is 4.2 Galilean units? Io. So I'm going to say something about Io is this. How do I write that? The orbital radius. So it's going to be, it's not in AU here. This is in Galilean units instead of AU. We will use, it's R. It's just a radius. Cool? And it's a radius of which moon? Io. 4.2, and I'm just going to call it units because I don't want to write GU. That's all I know. Well, what am I trying to find? I want to find the orbital radius R of Ganymede, and I'll capitalize that. Baller. Now, if you would like a picture, I'll sketch one here in a second, but it does not add anything to this. All right, so we know 2 periods and a radius. We're trying to find the other radius. If only one of those 2 equations that we wrote at the very top would apply to this. I think there's an equation that we might be able to use. Kalisha, did you write the equations at the top of your page? Whoa, that's fine. Okay, can you tell me which equation you think we might use if we know 2 period and 1 orbital radius? You can either read it letter per letter, or you can give me the wordy version. Do you have these 2 written on top of your page? Yeah. Okay, so are we going to use Kepler or orbital period? Do you know centripetal acceleration? Okay, so we'll fix it. Rafa, hook it up. Kepler's third law. Now, I'm going to think ahead real quick, and it doesn't matter. You can reflect stuff, right? That's a reflexive property. A equals B is the same thing as B equals A. We're trying to solve for the radius of Ganymede. And I will use my subscripts here, just so it doesn't get super ugly. The radius of Ganymede is what I'm after. You do not have to, but I would suggest, and it's always going to be easier, if you have ratios and proportions like this, whatever you're solving for, put it in a numerator. You can do it the other way. You're just going to have to do one more step to cross multiply to get it out. Keep it in the numerator. It'll make stuff easier. So the radius of Ganymede over the radius of Io, and I do what with the radii? Cube them. Good. It's the cube of the radii, right? Equals the period of what should go up top over here. One more time. So you're right. I'm going to sneak in here, though. Ganymede over the period of Io. And what happens with the ratio of their periods? It's squared. Okay. Mathematically, the only thing that I would be worried about you getting wrong, and I'm going to just preface this before you guys do the problem. If you were looking at this, what gets cubed over here? Everything. So meaning RG and RI. What gets squared over here? Everything, meaning TG and TI. Cool. When I do these problems, I don't plug in a number until the very end because I think it's terrible and I get goofed up with decimals and numbers. I want you guys to solve this for the radius of Ganymede. Cool. I'll give you a minute. Talk it out. None of the algebra in here is beyond, I don't know, probably algebra 2? Algebra 1, somewhere in there. Cool. I'll give you a minute. Whether you use cube root button or to the power of 1/3 over all the stuff is entirely up to you. I'll plug this in and I'll be right there. Huggins. 4.2 times the cube root of, let's see, we had 32. I agree with you, I think. I heard two people say it. 28.61. Now, as we're looking at this, I want to think, does this number seem even a little bit reasonable? First off, what are my units? I'm not going to write them all out. What did we just find? RG, and what's RG? Good. The orbital radius of Ganymede. Now, if we're looking at it, do you guys agree that Ganymede takes a lot longer than Io to go around? So just using our powers of deduction, if it takes a lot longer to go around, it should be a lot further away. Now, that is just a rough idea. If I'd gotten a number that was like 25,000 or something, I would be alarmed by it. This number, I think we could argue, is a lot larger in this context than 1.8. I'm pretty comfortable with that. 4.2. I'm just going to say U right here, and that was my shorthand for which sort of unit? Galilean. So, sorry, my writing, did you guys have enough space to do it? Whoops. Yeah, I had that thought. My bad on the formatting, if this took everybody into the second line. Oh, no, it's nobody's I see on the bottom yet. I will do better with the spacing. The radius. And it's the orbital radius of Ganymede. Is 28.61, and I'm going to steal your idea, Huggins. Galilean units. Baller. Now, looking at this, we didn't use AU, we used GU in this situation. Yeah, spot on. Is there stuff in this that mathematically you look at and go, nope, not a chance? Everybody comfortable doing a cube root? Okay, totally. I didn't have the answer when we checked. We're going to come dig into yours here in just a minute because I think you got something different, right? And we're going to find out why. It's a calculator issue. I'm almost certain of it. Okay. Doable. Prove it. I want you guys to knock out number 2 for me. Just kidding, number 3. Yep, I added this problem, which is why the spacing got gross. That's my bad. Cool. Knockout number 3, and we'll come back together in just a moment. Find me the period of this asteroid by class tomorrow.